Hello everybody, welcome to the Austin IoT Hardware Focus Group meeting. How many of you guys have been, this is the first time here? Wow, good number, 30% of you are new. So you may not be familiar with what the Austin IoT Group is. We have a main group that meets at Sherlock's. And we have a secondary group that meets, several secondary groups. We have a connected car group, we have a industrial IoT focus group, and we have the hardware focus group, which is the meeting you're at now. This meeting, we primarily focus obviously on hardware, and we like to do show and tell demonstrations, collaborative discussions, and educational presentations. And the focus is creating IoT devices for fun and profit. So we're not about closed things. We're generally speaking open and collaborative. This is the tech shop. How many have ever been here? Have not been here before? Not been here. Okay. Please go up front after this presentation and tell them to give you a tour. Ask them to give you a tour. They will give you a tour. This place is $1 million worth of equipment that's at the disposal of its members. Everything from laser cutters to water jet cutters to 4-axis CNC mills. They've got. It's a dream come true for anybody who needs to make something. Okay, tonight's agenda. I'll just let you look at that real quick and we'll just skip right on in. We've already done the announcements and the call for jobs stuff, so we're ready for Charles to do a demonstration. Actually, I've got those out of order. But Charles, I'll just reverse the order when I have to. My computer will stabilize. Okay, well Charles is going to take over now.
All right. I don't have any slides. Can you just kill the monitor?
I can try.
Hey Charles, you look familiar. What's your connection with the Austin IoT
It's the
group?
first presenter. I think I saw the presenter.
I did.
Yes, you did. All right. Well, my name is Charles Fowler. I've been in Austin about 6 years and been working on this little project right here. I'll get on the camera, I guess. I got a couple things to pass around. So let's start with some basics. How many people in here are familiar with LoRa or LoRaWAN, LPWAN? Okay, so about half the room. How many people in here are familiar with RF propagation, power versus loss, option? How many people have bad Wi-Fi at their house? Okay. So you go to your friend's house, neighbor's house, maybe they got different construction, right? I mean, I won't get into too much of the details, but basically, everyone around you likes to crank up their power to blast the Wi-Fi, and it's shared spectrum, which is it's garbage, right? Well, LoRa's kind of neat.
Sometimes you just want to create something different.
Yes.
Something powerful. Something.
You're not up yet, Charles.
Sorry about that.
So what I've got here, I've got 2 different LoRa systems, and I've got a IoT board. How many guys, Texas Instruments, you all familiar with that? Okay, how about the sensor tag? You guys ever heard of that?
Yeah.
Okay, this thing's pretty cool. It has a 2032 battery, BIOS battery. You guys probably all seen one, maybe your watch has one, it's a really big one. 1 second intervals, polling intervals, for 365 days off of the 2032 battery. For $25 or something like that. Just pass this around. This has got a whole bunch of sensors in it.
What's it called?
Sensor tag from Texas Instruments.
What is the radio in it?
It's a Bluetooth Low Energy. And that's a great question. That connects up to Pi, which sends that telemetry data along with GPS, and I'll pass this around in a second, over LoRa to the ground station. So this board here, so the first board I want to use was this guy right here, NetBlocks. They're out of Bulgaria. I guess we're recording, I guess I'll talk about this. This put me on a watch list with the US government. I travel constantly, I was never hassled. As soon as I bought this, every time I fly, I get hassled now, bag searched. So, mildly annoying, but this is about $45. This is the first full board I could find. And by that I mean, you guys bought components and stuff like that before on reels, or you learn how to hand solder and all that. I didn't want to do that just for proof of concept. So I got this board. It's got USB in. It's got the 7-Tech. There's a couple different variants. I forget which one this has. And of course an antenna. Nothing too fancy. Shows up as a RS-232 device to your host. Windows, Linux, whatever, Mac, doesn't matter. It can work So I'll pass this around as well. Now, the nice thing about that, very simple, plug and play. You know, like I said, you have one on each end. You send data out side A, shows up on side B. You guys get in and work with RF serial pickups, stuff like that before. You know, you send data, it's just a straight copy. Very simple, very streamlined. Now, let me give you a bit of background on this project. How many people saw, I'm going to hold this up, just so everyone can kind of see it. Hopefully it doesn't shatter. It's made out of balsa. I'm disconnecting a couple of components, I'll go through those. But this here is a device designed to operate 85,000 feet in the air and provide Wi-Fi links between regions. Say Austin to San Antonio or whatever the case may be. I'm going to put this back in its protected case now. Sorry, I won't be passing this around. So what's in it? And if you guys have any questions, whatever, interrupt me anytime. Raspberry Pi, familiar? Everybody? Okay. Arduinos, everybody's familiar with those? So this is what's called a hatch or hardware attached on top. Is this new to the Pi 3? Do you know?
No, it came out on Pi 2.
Okay. Well, this is a Pi 3 on the bottom here. We have this hat or hardware attached on top. And I'm going to pass this around now. Now that has two radios on it. Radio 1, GPS. It's not U-Blocks, it's another competitor. It's got better performance on bringing out, because if it switches between internal and external, it keeps the fix, and yada, yada, yada. And then a LoRa radio. So the idea is that he's constantly, of course, recording his position as he's moving through the jet stream around the world. It takes about 10 days to orbit the Earth, about roughly 35 miles an hour. As he's transmitting, ground stations are receiving the downlink and driving a Pi on the ground, an Arduino, and an Arduino Shield, which is operating servo, gearbox. You guys worked with these before? Anybody? Okay. So I'm going to get into RF here just a little bit. I'll try not to go over anyone's heads. I'm going to have a pencil or pen. Okay. So you see how thin that is, right? That's your beam width between the ground and the air. So the precision required to track the orbiter is extremely high. So that servo gearbox combo is about $200, and there's a pan tilt system and stuff that I didn't bring. It's about $500 worth of electronics. Because when I tell the antenna, move, up, down, left, right, okay, I need it to move right now. When I tell it to stop, I need it to stop. We tested this system a couple weeks ago on an airborne payload, and we were in Houston, and it rained briefly, so we'd thrown a tarp over our ground station. Well, at some point during the flight, the balloon was about to burst, come back down, we started cleaning up. Well, my friend picked up the tarp, just barely, okay, Yagi, anybody familiar with Yagi antennas here? Okay. Just barely, tarp's very lightweight, whatever, just barely grazed the Yagi, we lost link. I mean, that is how precise this beam needs to be. It has to be locked on. Now, granted, the Yagi was improperly deployed, it wasn't locked into place, but mistakes happen, right? So these systems are designed to be 100% automated, no humans anywhere near them, because the chance for mistake is that high, even with just a simple action. Now, why am I doing this? Okay, we said Wi-Fi between regions, right? Main reason for this is I talked about at the very first presentation I gave. Okay, how many people here have worked with IoT devices of various kinds? Okay, how many of those have worked with it that have Wi-Fi as their primary communication? Okay, cell modem. Okay, what else? Any other? Yep, Zigbee. The idea of this is to deliver a few megabits of bandwidth anywhere in the continental United States. So all these things. Sir, what's your name? Heads up that you were talking. What's your name?
Dan Vogler?
Yeah. So you were talking about the power grid, and you'll need millions of telemetry devices potentially, right?
It exceeds our population. It's a big
Right.
opportunity.
Exactly. So all of these need backhaul. Now I imagine you have to pay $300 a month to AT&T for T1 line for one of these sites, okay? Or even with machine to machine with T-Mobile and the other carriers, that's still $3 a month per station. That's a lot of money. okay? And it's ongoing. How many people in here have worked for long-term with cell modem backhaul? Okay. It likes to fail. It likes to go out. It likes to drop off. It likes to drop bandwidth. There's all kinds of issues with it. Not that Wi-Fi is necessarily better, but I have found in my experience that it's a lot more reliable. But of course, it's not ubiquitous. So the goal of this project is to make it ubiquitous. So we've developed something that we call an internet box, which is about, with solar cells, batteries, and everything, about $5,000. But it gets you a complete ground station, electronics tracking system, and orbiter. You actually fund the orbiter. There's various regulatory reasons why we can't just let everyone go launch them. There's a couple spots in the U.S. that were cleared to launch because of no-fly zones. And I can, if you guys have questions about the regulatory environment, I'm happy to do it. But the idea is that this thing is orbiting, talking balloon to balloon to balloon to balloon, back to all your major internet hubs. Kansas City, Chicago, St. Louis, Los Angeles, Houston, all your big sites. Put one of these in, link it to the fiber, you've got your backbone. That's it in a nutshell. Like I said, the LoRa component of this is kind of small, but it's highly critical for two reasons. One, it lets us know where the orbiter is. Two, it provides a link that's outside the data path. You guys ever work with telco networks or computer networks? Ever been hacked, had a denial of service attack, things like that? Okay, at that point, you really want what's called an out-of-band network. You don't want to be accessing your systems in band over the same medium that the attackers are using to shut you down. So LoRa gives us that. LoRa gives us an ISM band, license-free, commercial use. Because sure, could I use hams? Any hams in here? Okay, APRS. You guys familiar with that? Okay. I can't use that commercially, right? I talk to them right now. No, just use APRS. I'd love to. I can't. Right. So this gives us an ISM commercial use band that lets us always know where the orbiter is. The FAA requires the ability to initiate cut down at any time, which is a critical. You're heading towards an aircraft, any number of reasons. You have to basically pop the balloon and have it come down. We're building a recovery system. Balloons, parasails, parafoils, you guys familiar with any of that? It's essentially a balloon parachute combination with some servos that let you basically steer it into a very fixed. The current system out there today, you get it into a 10-meter radius, so we can have it telemetry, right? So if something's gone wrong with one of the cells, the batteries, we can basically initiate cut down over the Pacific Ocean and have it glide into our service recovery center. And then, of course, the ground piece is a LoRa receiver. And now, as the balloon's going in its orbit, the downlink stations in the footprint all receive the downlink telemetry. They're talking to each other. The server will discard any duplicates, so you get automatic handoff, you get automatic retrain. You get a lot of benefits that if you're trying to build out in the Wi-Fi has been a big challenge for us, which is one of the reasons we haven't launched yet. With LoRa, you get all that for free. MQTT, anybody familiar with that? Okay, yeah, you guys all, many of you went to that workshop. So, okay. So there's LoRa to MQTT bridges, so we're using that. We subscribe to MQTT stream, we log everything for machine learning, for regulatory reasons, etc. Yeah, we're using a stack I found. I forget who mentioned, some university in France. They added a QoS, they added encryption, they added carrier sense, CSMA avoidance to LoRa. That's all open source, designed by Pi. Sorry, I just teach you guys a ton of info. Questions, comments? Am I crazy?
You're using the LoRa as the link between the balloon and the ground?
For command and control, and then Wi-Fi for data.
And so that means you have to have a link, you have to be connected to it. So the range you're talking about is far greater than 20 kilometers.
Yes. On our test, it's gone up to about 96 kilometers. That's assuming clear line of sight. Type
Or
track.
using a Yagi.
Exactly.
What's the gain of the Yagi approximately?
I don't know off the top of my head.
Quite a lot.
Oh, yes.
That narrow.
What was the French company that you got your stack from? The name of it?
It was a university. I googled like LoRa, Raspberry Pi, something like that, and I found it. It comes up in a number of searches. They had actually a really good article on all the different LoRa boards out there, different config, some were components that you need to solder, some were turnkey, some were with Arduino, which actually led me to not buy some of the boards I was originally considering when I was doing my research. I'm sorry, I can't remember. I can look it up and let you guys know shortly. Yes, sir.
Did you say that your balloons are actually orbiting the Earth? How do you keep them alive for that long? I understood that they basically, once they reach a certain altitude, they'll
Absolutely.
pop.
Let me go into that. I mean, I'd be happy to get into the balloon part. I don't want to take too much time, but are you guys interested?
Definitely interesting.
Awesome. So, as you can see, we've got the orbiter here. Now, the orbiter has a series of holes at the top of these fins. So what happens is, you've got two parts. You've got a spine down the middle, you've got the payload in the bottom, and you've got a harness up here. Now that harness is for two functions. One, it protects the envelope, right? So any material you put up there, latex, things like that, UV exposure destroys it. At 85,000 feet, UV is both your best friend and your worst enemy. It's your best friend for solar because you hit theoretical maximum of whatever the manufacturer specs, but it's also your worst enemy because it's counting your envelope. So we have a nylon custom fabric around the envelope, and the envelope is inside. And then we have solar cells over it. Now the balloon is known as a zero pressure balloon, so it's designed to not overinflate. Because you're absolutely correct. What happens in most of our tests, we just use weather balloons. They go up to about 105,000 feet. They burst, come back down, stop a 2-hour round trip. Now we use that to test sensors, to test comms, to test a number of things. But yeah, it's a very complicated. It uses gores, individual pieces, which are essentially cells, and then those are actually plastic welded together. We're working on that piece now, finalizing it and open sourcing it.
So it's just a balloon that can survive in the absolute vacuum?
Well, it's at 85,000 feet, so it's not necessarily an absolute vacuum, but it's certainly very hostile to anyone who want to live up there.
Cool.
But yeah, and with the harness, no one else is doing that. But they're trying to live. So, for example, NASA's had a balloon up for over 100 days with like a 2,000 kilogram payload. It's a telescope, so they want to be above the troposphere, not have that interference. Our payload is 5 pounds, 4 pounds, somewhere in that range. So much smaller balloons.
And how long do you expect it to stay up for?
We're shooting for 90 days.
90
We're shooting for 90 days. The economics don't really work out.
How does this compare to Google's X program for?
Project Balloon, it's
Yeah.
very similar. Project Balloon uses licensed frequencies, which means if they get too popular, their licensees can shut them down, or licensors can shut them down. Those licenses are not perpetual; they are renewed on a 1 year, 2 year, 5 year basis. So they're our primary. We also compete with them in all the Google Fiber cities. So we've made quite a successful business out of competing with them faster, cheaper.
By putting a balloon up and having it delivered.
Yeah, well, also terrestrial Wi-Fi. Well, not quite this. This is my demo unit, but towers like this on the ground, actually providing internet and connecting up with large ISPs, and then using that as a backbone.
It's like I have a place in Elgin.
Mm-hmm.
I can put one of these in and get internet out there.
Possibly, but yeah, that was the idea that we cover a lot of rural areas. Not currently in Austin. We're covering some areas in urban core. We're experimenting. Because Google isn't nearly as big here. They're getting big, so we're now ramping up. But yeah, the idea is that you can fast drop out all these places that we can
Do you have a website?
Yes, suborbital-systems.net. Like pictures, build materials, build instructions, links to LoRa stuff. I'm working on a couple of LoRa posts right now. I have a lot of information I'm trying to pare down. Dave?
Over the lifetime of one of your balloons, how far does it travel?
Well, we go around the Earth about 9 times.
Wi-Fi 2.4 gigahertz. How much is that affected by clouds and rain?
Sure, we're actually using 3.65, which is a licensed light frequency from UCC. It's the upper half of the C-band. There's a couple issues with it in that there's exclusion zones on the coast because the telcos use that for international voice downlink. So we can't use it there, we can use it in the rest of the country. We're also looking at using the citizens broadband service that came out from the law administration. The hardware isn't out for that yet. We're following the FCC process, following the orders, commenting, things like that.
So you need special ground equipment to receive it.
Yeah, you just swap out the radio basically. It's Ubiquiti makes the hardware you need. It's really, it's off the shelf. The licensing is like $200 for 10 years of it. It's very, and that just allows you, if there's interference, you can look at a database, see if there's interfering, things like that. So it's essentially almost just a maintenance fee.
But to use it for an IoT type of system, you have to use not Wi-Fi.
So we're using 3650 from the towers to the balloon. It's 802.11 at the edge.
Oh.
Yeah, sorry. And we're also, I mean, Zigbee's so cheap and LoRa's so cheap that we can just throw that in essentially for free so that we can create. The Things Network, you guys familiar with that? Okay, they have actually 2 spots in Austin, and they've got some other spots around the country. We're looking to massively grow that network this effort. So.
But so the question about the 2.5 gigahertz on the downlink side,
So that, we don't use it there, we use 365.
excuse me, on the edge side.
Mhm.
So if customers that are receiving Wi-Fi or data from the thing, how are they affected by
Sure.
weather?
I mean, yeah, so 5 gigahertz is better there, but of course you have range issues with that, right? Ideally, you know, we're pushing that. So like, let's say you have a fairly large site, maybe you have your own, you deploy your own frequent tower, which would be 3650 point to point, and then you can distribute Wi-Fi that way. But also you could be using LoRa and Zigbee, right? Which may be a lot better
So
for.
2.5 is a problem because it's water absorption frequency, so.
Right.
Getting
Hits a
the
human and
dense-
it stops, or goes over water and fails, absolutely.
Or cloud,
Yeah.
cloud is not gonna go through.
Yeah, and for that it would be more, we're looking at kind of for Wi-Fi to be the last, you know, few hundred feet. We have a product called Pocket Mesh, which is a Raspberry Pi Wi-Fi shield setup that allows you to do that and then link on back to us via 3.65. Each situation is going to be slightly different, which is why we don't have a fixed solution for the last, what we call the last square mile. That could be 5 gigahertz, 2.4. Yes, sir.
How many people work on this project? Where are you getting funded?
Number of people are working on it. Funding is from a
Are
variety
you
of
talking
sources.
about tens of hundreds or?
Well, I mean, so a lot of what we're doing is integration, right? A lot of this stuff is already exists, already open source. We're just taking time together, making easy to use. So it's been somewhat self-funded and then also just through consulting to pay the bills essentially. It is expensive. It's a capital-intensive project.
Thank you.
Not, I mean, we're talking to some funders right now to take this to market. We've gotten it to obviously the prototype stage here, and some of our other products. We've done some installations, things like that.
Is this something you could do with Kickstarter or?
Possibly. Kickstarter generally doesn't raise enough money for something of this complexity to come to market, right? Because we're looking at an MSRP of anywhere from 3,000 without electronics up to 10,000 with a full electronics package. Most people aren't going to be able to kickstart that effectively.
Right.
So at scale, we can bring that cost down, but we're talking to this to bring this to market. Contract manufacturers too, in China and the U.S. Probably in the U.S. because our primary first target customers for this are U.S. Geological Survey, Fish and Wildlife Service, right? Your government agencies that have huge deployments in the flyover country that desperately need this, and we're looking to get them to fund the first round through DARPA contracts or something like that, or just a straight up service delivery contract. Because there's a lot of sunk costs to this. Once those sunk costs are in place, the incremental costs are almost nothing, right? I mean, if you think about the ground stations, the antennas, the trackers, batteries, solar cells, I mean, that's expensive. But once you put those in, as technology upgrades, you just swap out the radios, right? And of course, 2 or 3 service and recovery centers, probably one in the west, one on the east coast, and one on the west side of the country. There's 10 spaceports in the U.S. We're talking to those to see who we're going to select as our service and operations or service and recovery centers. And we have our own operations center that we built in San Antonio. Yes, sir.
How are you getting a Wi-Fi signal to go 12 miles? If I'm understanding this correctly.
Through
He didn't say that.
it's actually pretty straightforward. I mean, we're using Yagis or you know, parabolics or whatever, depending on the condition. Like I said, the beam width is about the size of a pencil,
Okay.
so it's very precise, and it's moving too. right? So that's why we have the tracking system and all that, and the GPS constantly transmitting on LoRa. Not only so much what we know the orbiter is, but where it's going to be, right? Because you are essentially tracking. Anyone shoot clay pigeons? Okay. So you know, you don't shoot where it was, you shoot where it's going to be.
Yeah.
Right. So think of it like that.
Do you acknowledge the packets, or is it a fire and forget on the down?
On the LoRa or the Wi-Fi side?
No, the Wi-Fi.
Don't know. That's a good question. We're looking at some different TDMA implementations. Some of them acknowledge, some of them don't. We just secured a 34-mile test site, so we're in the process of setting up gear there. I'll be able to answer that better next time.
Any other questions? Thank you, Charles.
Thanks, Jeff. And if I can get my handouts back at some point.
I got 2 of them here.
And next up, we have John Steibel.
You can finish passing around. I think I'm the last person.
Okay. All right, so. I'm going to show off a little project we kind of whipped together on short-term notice to act as a LoRa gateway. This was designed to attach to 30 or 40 sensors of all sorts of variety, whatever sensor we could get was designed to go into this device. So now you'll see this Raspberry Pi and LoRa board is the one you just passed around. That wasn't planned, it's just that's the kind of default board all the cool kids are using these days. They're easily available off AliExpress, about $30 for the LoRa hat. And you know, the drivers are readily available, they're good, they're stable. We're running this in a .NET environment, so we recompile them. It all worked smoothly. The one variation from what you've seen over there is this is to collect data directly from sensors and then uplink it via a cellular modem off.
Because my product hasn't shipped yet.
What's that?
Because my product service hasn't shipped yet.
Well, yeah, we've had these running outside kind of all summer. They performed really well, very stable. But we learned a lot from this device. We're building some other things, and this was really a device to learn on. So it's not a commercial product. It's just to test the sensors and whatnot. So in its full implementation, this sits inside the box and connects to a 50-watt solar panel. That's about a solar panel this big. Things we learned is, number one, Verizon is really difficult to work with. In its standard implementation, you don't get a public IP, and you have to have a static IP, otherwise, you know, you're really not going to get access remotely to this device, because, you know, while you can SSH into Raspberry Pis and whatnot really easily, if you don't have a stable IP, there's some hacks and other things you can do, but it's not going to happen easily. So that's $500 fee from Verizon. The other thing that was really critical on this that we learned was, well, we knew this going into it, the thermals on these low-grade cellular modems are really, really sensitive. Moreover, the drivers on the various modems for the Raspberry Pi tend not to work. There's websites out there that say they work, they don't work. The newest MiFi from Verizon, the UC610, works pretty well, and the thermals are pretty good. But that's about a $70 device used off eBay, whereas because these devices are about 10 bucks off eBay used, and we really struggled to get this to work with Raspberry Pi. We eventually did, but we weren't the only ones that struggled. You know, the message boards just scroll on for 30 or 40 pages with all sorts of problems. The problems come is these MiFis want to switch between the 3G and 4G network, and the Raspberry Pi just can't handle that switching. Another thing we learned about Verizon is the 4G network isn't very good. It's not deployed yet. Coverage on 3G is much better. We knew that going into it. Otherwise, all these pieces here is basically just a solar regulator and a DC to DC converter, directly off Amazon. I think this was about 12 bucks. This was about 5 bucks. The reason why we chose all these components was because of Amazon Prime. We got free shipping because we were doing this at the kind of last minute. So it tended to be, the 2-day shipping was actually quite handy.
Is that all off the shelf? Any soldering? And just plug and play?
No soldering whatsoever. Just wiring it together. This version wasn't production. We used a little more hot glue in the production models, but that was basically it. And we did laser cut these plastic panels. The guys on our team did that just to kind of hold it all in place because, particularly with this big battery in here, this will run about a month. But what we found running the Raspberry Pi, we were running some other software. We could easily pull 5 watts. Off of it. So we did need a fairly good sized battery, and we didn't know what to expect in terms of clouds and worst case scenarios. So we oversized the battery and oversized the solar panel, but it's probably the right choice ultimately because it kept the unit fairly stable. So a little bit about the protocol. So we're not running LoRaWAN on here. We're actually doing a encrypted UDP version that runs over the LoRa. There's various reasons for that, but fundamentally LoRaWAN is kind of fancy and it delivers some nice capabilities when you're managing hundreds and thousands of sensors. If you're managing a dozen sensors, it just adds a whole lot of complexity that is typically not worth it depending on what you're doing. My background, I worked in IoT for a long time, and despite all the beautiful press releases out there in the world and case studies saying, XYZ big company has made something smart, most of those aren't at scale anywhere near what they might suggest to be. For IoT projects, if you're running a couple hundred sensors, that's a big project. Having thousands of sensors out there outside of government projects. The U.S. government runs a fish and wildlife network that is quite large, but don't be seduced by the notion of LoRaWAN, because it can really add a lot of cycles to your project. Let's see, what else? The other thing, so we're running, we're feeding this data into Microsoft Azure, and that's worked fairly well, but again, that's not an easy system to work with. It's particularly, we're using the kind of standard libraries on here and whatnot, and the libraries are, from Azure are far more stable in the Windows 10 embedded implementation. They do work on Linux, but they're not quite as stable as we might like. We did catch some problems in the implementation.
Did you go with that because of the Azure backend?
Well, we actually ultimately emulated in Mono, and then.
But did you choose that platform because of the Azure backend or some other reason?
Yes, because of the Azure backend. We ultimately thought Microsoft's libraries will be the most stable on its own products, so we should do that. There were some added other benefits because we have a number of apps that run on top of it, and just in terms of availability of developers and speed and whatnot that we're building this, that also factored into the choice of what we did on the apps. The apps run in a number of different languages, which the Pi supports, and that's worked pretty well. But it's driven by various partners that we have and some other factors outside of just a pure technical driven decision. The problem or the challenge with Azure is it's just very fiddly in terms of getting the data up. Its default position is it rejects data for all sorts of reasons. One of the reasons is the data is more than about 10 minutes old, which is great, but they don't actually tell you the data has been rejected. So we spent a lot of time figuring out that the clock was off on the Raspberry Pi, so we got no data whatsoever. So clock settings is something quite critical that you wouldn't necessarily think of to check, but we updated the clock and yep, data just started going.
Are you using the GPSs at the time?
Yes, so there's a funny story about GPS. We initially started, we accidentally had it reporting every 5 seconds. It was until the Verizon bill came. And that cost us about $200 in that era. But yeah, the data, I mean, in this implementation, the box can move for various factors, so we do have GPS reporting about every 5 minutes.
But the time is more important than that. To be able to get highly precise.
Yeah, I mean, it does have the time. We don't need it. We're just using the NTP server off Linux. That's good enough. It just seems when you fall out of that side, that 10-minute window, that's where we had trouble with this one. And a lot of that we actually solved in diagnosing the MiFi problems with Verizon. That was kind of one of the things that we worked through on the list at the same time. So, all in all, for this implementation, all in, for Walmart battery and the thing, the total cost here is probably $150 max. Compared to commercial gateways that you buy at probably $800, $900, good multi-tech cellular connected routers, that's easily going to be $800 or $900. This worked pretty well. It has its own, it has its thermal issues and has some structural issues and whatnot, kind of known issues of design, but all in all, for that price, I would very much recommend this approach because, being on solar makes things infinitely easier. You don't need to call an electrician to install this stuff, and there's various other problems that you both create, but you also solve as well. So, my background is kind of doing things at scale, large sensor networks and whatnot. So having these spread around, whatever, whether it's city or country or whatnot, to me that's quite interesting. I'm more interested in how they operate at, once scaled up with lots of units more than the individual unit.
So do you set them all to the same channel, or do you try to do a couple channels and cycle, do a duty cycle? How do you?
Yeah, so right now on this one, it's one
Well, because
channel.
you're not actually doing LoRa WAN, right? You're doing your own protocol.
Correct, yeah, it's proprietary. But, the main limiting factor is, each sensor, if, depending on how often they're reporting, if it's every 15 minutes, eventually as you put more and more sensors out in the field, you'll start having clashes of reporting times. And then you'll have, acknowledgement and a repeat cycle, and that just gets you more and more congested. So until you're, at, what is it? I mean, it's just the basic math of whatever, but it's, a couple hundred sensors. You really don't have those clashing problems if you're just kind of randomizing the time over a window.
And do you do some sort of like, you're talking about encryption, so there must be a key value shake or something so that someone else can't just pop up with another node and go.
Yeah, correct. So there's actually multiple encryption keys, both from Azure as well as the protocol and whatnot.
I mean, do you have a need to go over 100 or 200 sensors? Because I know there are techniques. I mean, the previous company I was with, we could put thousands
Oh, yeah.
of sensors on a single RF channel.
Yeah, I mean, that would be, the next implementation would be a LoRaWAN implementation and whatnot, and that would support it, because, that really goes to multiple, one listen frequency, one transmit frequency, and you randomize.
But that's what we're doing, and we have CSMA, so if anyone else is talking, we're not gonna talk.
Yeah. Which is good. I mean, it's not a priority for us at the moment. It will be, kind of starting to be next year. But, right now, all of our sensors are fairly low bandwidth. We're actually more worried about battery power than anything else, because, once you start having a lot of radios running full time, your power budget starts shrinking, and then on the other end, your
And
sensors.
you're driving an RF emitter, which is expensive.
Yeah, because the sensors we're talking to need to operate for multiple years and whatnot. So particularly on the gateway, you want to get transmitters and receivers shut off as much as possible, and there's various techniques of how you could set the timing of when it reports. You could have sensors report at the top of the hour in a randomized 5-minute period and whatnot. But at least for what we're doing, we don't have massive use cases of what we need. No, if this was urban environments and utility context or whatever, yeah, I could absolutely see that. That's not our challenge that we're trying to solve at the moment. For us, it's more about reliability, connectivity, and long distance of range in various environments and whatnot.
Who's us?
Us is my company, so my team and whatnot.
What is the company name?
So my company name is called Solz. Solz, S-O-L-V-Z.
SOLVZ.
Yes,
Okay.
Solz.com.
And the LoRa modulation scheme, are you using the LoRa Alliance standard, or Ingenu, or Sigfox, or there's a lot
we're
of
using-
flavors?
So we are not using the certified LoRa Alliance protocol. We could be. We just haven't done it yet. For us, if you're making a mass market product, you want to be LoRa certified and whatnot, I can see lots of reasons to do that.
But you're also kind of a closed system too, right? I mean, you don't necessarily need to operate with
Yeah.
like telco, LoRa, or anything like that.
Yeah, exactly.
What's the main application you see for this, being solar powered and thus off the grid in remote telemetry uses?
Well, this is for this unit. It's the same as any IoT application. So it's things like agriculture, smart buildings, various other kind of.
But a building has power. Doesn't need the.
So, like, for example, my ground stations would buy one of these for every one, because we want to know, hey, is it flooded? Has a door been opened? All these kind of things can all be deployed and into the environment, into the perimeter, things like that.
Yeah, but
A large grower might have 10 buildings too.
Yeah, exactly.
sure. But you also have, when you think about the total cost of ownership,
Without power.
installing wired sensors gets really expensive very quickly. So if you're in, a smart building context and you want to install 100 sensors in a building, your costs are probably 100x if you have to wire them in as opposed to battery power. When you can get battery power lives up to 5 and 10 years, why bother?
What sensors are you using to hit?
For us, for this unit, it's really agnostic as to it could be any sensor. What you do, though, quickly realize is the hardware isn't the problem in IoT, it's the software. All this stuff is off-the-shelf stuff, but okay, so you collect a bunch of data, now you have a mountain of data, you send it up to cloud storage, what do you do with it? You don't know what it is. Your sensors report all sorts of data that you can kind of fiddle out what it is, but until you have a protocol that tells you what it is and makes it replicatable, so other people can understand what the data is, it has a negative value. It doesn't have a
You can just log in QGT and all your topics and everything, and then subscribing to them, and what do you graph, what do you store long term.
Yeah. So in what we have announced is, we do a lot of weather collection at scale. So we've announced with the Open Ag Data Alliance a weather protocol for how you report weather. So that's things like temperature, rain, wind, cloud cover, kind of all the kind of commercial meteorological things you do. But very quickly you realize, there's a lot of kind of debate about what IoT means or what it is. And to me, IoT is kind of enabling big companies and big things to dance together. And until you're doing that, you're, to me, not really changing something or creating something new that hasn't already existed before. And so, perhaps I would say like it's, don't forget about the software layer and what you can do with the data and how you can change workflows of what you're doing with your system more than just doing a point-to-point monitoring of something, right? Because basic kind of 400 meg, 900 meg radios have existed for 30 years, and okay, the costs have come down recently, but what more are you doing to make the tipping point of where you'll get good adoption in IoT?
Have you used any cellular radios other than the Verizon product? I know AT&T is trying to get in this space.
Yeah, they're all the same. They're all the same chipset. They're all the quad band. I had about 5,000 of these deployed nationwide, and they all had the same issues across all carriers. It's all the same hardware underneath. It's just a different label on the outside.
So you want to be, I guess, neutral or agnostic as to who the cell phone carrier is.
Yeah, I mean, there's various factors in that decision. The technology isn't really one of them. It's coverage, it's pricing, it's just account teams and their willingness to support you, which is actually quite important.
Just having a portal, like what we did, we bought tons of them and had them on the shelf, and when we ship units out, we could activate them ourselves, which took forever to get that negotiated. Otherwise, we would have had to call the call center every time and activate it. Now we're just in a mess. And not everybody will do that.
Yeah, and don't discount the difficulty of working with cellular companies. They're big machines, and unless you fit in their path, you're not going to get a call back. But that said, there's at least in the U.S. there's only 2 games in town, right? Or at least major games. Sprint and T-Mobile are a lot easier to deal with, but their coverage isn't necessarily there. And so.
I think it's interesting, though, that SoftBank, a Japanese company that owns Sprint, recently bought ARM for $34 billion with this long-range IoT strategy. So I would test that, are they committed to this in Sprint?
Yeah, I mean, I don't know. I'm kind of jaded on IoT generally because the hype, the term is just so hyped up. I don't see the actual use cases out there that just blows away. Because I think you mentioned that when I first started doing IoT, it used to be called end-to-end.
Yep.
And we would do lots of good projects. But you never really had the volumes above, a few hundred, maybe 1,000 at the most. And the technology now versus 10 years ago, okay, it's improved, it's changed, but it's not 10x. From there, and I think until you get a 10x change from a decade ago, you're not going to get the 10,000 or 100,000 volume projects that you really need to kind of scale things up and get management layers going on a software level and whatnot.
And some category killers to emerge. I mean, right now you start researching LoRa, and it's a couple of weeks of reading and trying to figure it out. I mean, you were talking about software stacks. I mean, it took me quite a while to find that, and it was a really good article. They talked about a lot of the issues. Because you were talking about the core spec, right? And a lot of people, I don't know anyone using it. I mean, because it's okay, but it's a reference implementation, right? So a lot of people are rolling their own for a number of reasons. Yeah.
And what do you think of Ingenu that seems to have a complete solution here in Texas?
Yeah, I mean, I've seen their presentation a few times now, and I think it's interesting. They're at 2.4 gigs, the maximum absorption of water. And, you know, in a city, that's gonna be tough, you know, somebody is,
Trash.
you know, if there's a tree between you and their tower, okay, it might work or it might not, but, you know, for Ingenu, you know, when they're charging a couple dollars a month, if they have a service call on that connection, okay, my whatever doesn't work, that's really hard to build a business model around that, even on a city level. So, you know, my background is in telecom and whatnot. So when you look at, you know, what they think people will pay for sensors versus how much it will cost to support that business model, I don't know, maybe it works, maybe it doesn't. I really hope it works. I mean, it'd be really interesting because, you know, they claim a link budget of 167 dBs sort of range. And, you know, that could open up a lot of use cases if it works. And I don't, you know.
It may work at sufficient scale, but they'll probably die before they hit that scale.
Yeah, well, I mean, you know, they'll get some really good coverage around the towers. So if you live in the right location, live in downtown areas, it'd be pretty good. If your sensor isn't in a basement, it will probably work pretty well. You know, I don't know. There's a Senate, SCNET, Senate, however it's pronounced. They're using Syntax LoRa protocol in their network rollout. And you know, I think all those have promise. I just don't know that there's a big enough customer set out there in need of really low bandwidth connectivity.
I'll talk about a lot of that in the
Okay.
fall.
Okay. So
One last question. I'm going to presume then that your business model or topology is two products, the LoRa cellular gateway bridge product, and then 100 just LoRa sensor devices around it in a star topology. Is that right?
that would be the obvious implementation. I mean, yeah. I mean, there's various use cases. I mean, there's many people making gateways. And I think that's going to be commoditized pretty quickly, so it'll be interesting to see how it develops.
Any other questions for John?
You mentioned you had thermal problems, and I see you got like a weatherproof box. You probably can't just put a fan on it. How are you dealing with that?
Well, if you put a fan on, then you got to deal with water ingress, right? So, you know, it wasn't very hot when we were using these, and you know, at night it cools off, the radio's turned back on, and particularly if you're buffering the data, you can collect a lot of historical data. In this case, a heat sink worked really well to fix it most of the time. But you know, on a 100-degree day, yeah, you're going to have a problem. But you know, you could also buy a $300-400 modem to stick in there, and that would solve the problem. But you know, when you're jumping up from $10 or $20 to $300, that's a pretty tough choice to solve 4 or 5 days a year.
Although I can tell you the Pi run, I've got one down at our operations center outside for GPS and NTP, and it runs at like 170 degrees, no problem. It's been running for, I don't know, 3 months, 4 months, all through summer. Not a single dropout.
Yeah.
I can also second John's experience with Verizon. I used to use them for huge data services with ship pilots in my company. So we had hundreds of these devices running continuously, sending data back to our servers. And Verizon has a built-in automatic screw the customer feature. I'm not kidding. Your bills are always wrong. You must dispute every bill, or else they'll just keep doing it to you. It is a nightmare. Okay, so the next presentation, thank you, John, is a short one from we're gonna get a cable connection swap here. So
Yeah, I've got VGA.
you got VGA, yeah.
That's what it wants to be.
Does it for you. take a few seconds. Anybody know how Linux to get the switch videos?
But if you cycle power, check.
Seconds, okay.
Yeah. Although Marion's better, I have to.
All right,
Excellent. Thank you.
excellent, that's all. I'll just go really quick. I'm just showing off point-to-point LoRa. This is a LoRa board here. This actually happens to be at 433 megahertz, and so I'm using a 6.5-inch piece of long wire to make a quarter wave antenna. I can put on a micro FL connector if I had the magnifying glass and enhance that, but anyway, it's just a quarter wave antenna, and every time it's getting a blip, and every time you're saying something here, what it's doing is it's transmitting out to a guy that can make Jeeps out in the parking lot, and that's what the other one of these are. And so they're just ping-ponging back and forth to each other. Sorry, I didn't know if I was gonna be able to make this meeting or not. I was gonna make it fancy and hook it up to a display here to where we could see what the RSSI was being recorded at each end. But the other end, by the way, I'm sorry, my name's Grayson Schlichting. So what this is doing is it's telling me that the one in my Jeep is reporting my RSSI at -677, -76. The other one is doing the same thing. And so what I hoped to do, like I said, was wire up this little guy. It's just a little matrix display that runs on the SPI port to the board, and then out with the display of what the Jeep thinks this is what the Jeep thinks my RSSI is, and then my RSSI in the Jeep is not being displayed here. But that was my goal, is to have both of them scrolling across here, but ran out of time on that one. So there's other folks who've got, I think, the same board here, that at 915 and other frequencies. Let me just,
Is this your own board that you made?
no, this is an Adafruit board,
Oh, okay.
and, now let's see, where my, I have this document open, let's see where it shows up at. This is a little bit of background information on it. Came up on either one of my screens, but not bigger. So I don't want to take up too much time here with that. Okay, it's on the screen. Now I just need to haul it over that one, right? What mode? Go haul it. So
There was it.
there we go. So one thing I think we do it back into go into full screen mode actually, since it was written. This is a real quick document. So this is the Adafruit board, and just in terms of some pricing on what these modules and things cost. You're paying for a lot of extra right here. Basically, the LoRa module is $5, and what I've paid extra for here is, here's the LoRa radio module, and this one they make in the 433 megahertz version. They make it in the 868 915 version, and then they got the LoRa Alliance version of this, which adds about another $19 to it, and six go low pan, which is about the same way. So those are the more standardized. This is standalone, like we were talking about, that you were using. So basically, the add-on board right here is $5. And what I've ordered it on is, this is an Adafruit feather. I don't know if anybody's familiar with their feather line. They're made to stack on top of each other. And so what we've got here is an ARM0 core, and that's what's doing the talking to this, although the module has got a lot of the intelligence in it. It's doing the encryption and hardware and everything out here. So what we're really doing is just kind of driving the pins, driving the data, doing a little bit of housework. The rest of this is things like reset buttons, programming, the Adafruit, the Arduino IDE part of it, the battery connector, which will automatically switch over from USB to battery, or when USB is plugged in, it charges the battery. So you're paying a lot of extra there. So
And is the data comes out the USB port, or?
the data does anything you want it to. Yeah.
I mean, does it come out the USB port to get it? Is it serial?
That's what we were looking at.
Okay.
I was just using the serial terminal port, and like I said, I wanted to work on the library, having them drive out this guy right here. I just ran out of time. Literally, in a couple hours, I would have had it. We would have been scrolling across back and forth, and we wouldn't have had the terminal programmed up there. So basically, like I said, the RF modules are $5, unless you're going to pay about $20 instead of $5 to get into the LoRa Alliance certified boards. If there's some reason that you need to be able to do that. These modules don't need to be in an Atmel PIC environment. These boards are generic enough that they can be put onto any type of system. And there's libraries out there, one called ARF24, ARF24 Radiohead. Lots and lots of library support for these guys. So no matter what system you wanted to put it in, you've got the driver support port out there. What's an arrow going to do to me? And again, I wrote this up as a write-up for a friend that I've known for 35 years. We've both been ham radio operators since we were 12, so I was just kind of pointing out some things to it, just showing him what the relative size of the board was. And here's where I had my receiver and transmitter. This was my antenna tuner. This is where I took my ruler and measured out 6.5 inches and so that's how I tuned the antenna. It's just and what is pretty good is, I mean, we're not that far away, being out of my Jeep in the parking lot. If I had a metal top, I would have set this on the roof of the car and it would have gotten a lot better. Because I would have had a ground plane. And here, of course, I don't have a ground plane, and when I'm holding it, I'm a ugly bag of water because of the ground plane. So you don't get a lot of range that direction. But what I did do was, and this is what I was talking about, you can, if one has the capabilities, you can solder in an SMA connector onto the board instead of using a long wire for a quarter wave or halfway, and then you get into high gain antenna and the whole picture changes.
So it's kind of like this. It's got an SMA connector on it.
Yeah. Yeah, but I'd have to, I brought the packets back there. I'd have to have a magnifying glass just to see the damn thing, and then get it down and get it soldered onto there. That was something I could have done when I was 14 years old, but not right now.
And that's why I bought this.
So my goal is to get somebody to maybe go ahead and put these on there for me, so I can attach radios. I've got this exact same setup. I've got the SMA connector, and then I've got this adapter. And being a ham radio operator, I've got a plurality of antennas. Plethora. That's what it is. And so in this configuration, what I've done is, and like I said, I was talking to someone else here, but, I was able to get about a half mile. And that again was with the transmitter sitting on top of my Jeep, which is a, fiberglass top, so that's not a ground plane whatsoever. Right now it's just sitting on the dashboard, and the other end of it was just me carrying this around in my hand, watching the red light. Because every time the red light goes off, that's a going ping pong back and forth between them. And that's where we're getting those RSSI numbers from. So if anybody's familiar with the domain, I was doing this test basically over at Neiman Marcus, and on the 5th floor of the garage there. So I was getting, like I said, about 0.48 miles. I didn't do a full radiation circle because if I'd gone too far west, it would have been me standing in the middle of Mopac. I wouldn't have worked out too well. But I had a line of shot. I could see all the way down to the Westin Hotel and Whole Foods, and I was able to go past both of those and was still getting the ACMAC. Now I wasn't watching the RSSI, but I still knew the package was getting through because they're both heart beating like this.
And that's with no ground plane and a very low power antenna.
A very low power antenna, and it was me literally carrying it around like
So
this.
worst conditions possible, and you could still go about half a mile. That's pretty impressive.
Yeah, and I was able to get some good through building. I was able to get through some buildings, and then there were some other buildings that there were parking garage, this was on a Saturday night. The parking garage was full of vehicles, so I didn't quite get this kind of range. But that's what I had, just outdoor range. I was only running at 20 dB, which is 100 milliwatts.
Bryce, did you scare that guy off the top of the parking garage?
Yeah.
Downtown?
Yeah. Is that you?
Oh, no.
Some guy
That, actually, yeah, I know. I could see that being me looking at my radio. Yeah. That could have very well been me. Then just some quick, what these guys are doing, exchanging packets every 500 milliseconds. They're sending that. Meanwhile, the ARM processor was not sleeping during any of this. The radios weren't being powered down at all. And so what you kind of see here at 100 milliwatts output, here's the M0 processor, and bang, here's the radio coming up and doing its transmission. It's doing the transmission, and then it's got the receiver, but I haven't put them in standby. But so you can see these power peaks, and they're getting about 130 milliamps. However, bringing the power down by half, so I was only doing 10 dB, and you can see that we still have the constant here, and this is the M0 processor, which is not being power managed at all, but I've got some more manageable current spikes, but I would expect that my range would have gone down. I didn't do any further ranging tests on that. This one here, the radio minutes, tremendous stuff. Yes, so here what's happening is that the radio modules are being turned off before they were in active receive mode. Here they're actually being turned off. They're coming on, and then here's the 140 milliamp burst. Here it is in the receive mode, doing that, and then after this many times I turn the radio back off. And you can see that the M0 is taking up about 10 milliamps.
So really not a lot more. I mean, you could see from the visual there, not much more power to run the radio. Because at the beginning and end, that's just the processor, right?
Right. So
there's not that much more to run the radio.
There's not that much more to leave the radio in receive mode. But this, so you got 10 milliamps with the ARM basically doing no loss. 25 milliamps when the receivers are in standby. And so what I haven't done yet is any kind of power management on the M0. I need to use its clock. In this case, if I'm In the Arduino environment, I can use something called Sleepy Dog, but basically I need to use the internal timers in the M0, turn that guy off, have him wake up, and measure time that way. Typically, you can get about, let's see, the M0's timer, I think you can get about 7 or 8 seconds of sleep time, and then the timer expires, and so you've got to either put it back to sleep again or go do something. So I think that you could get a lot of battery life by bringing this down into the micro and sort of range. And that's about it. The next thing I want to do is use my RTL SDR. I got one back there. Plugs into the USB port and gives you a spectrum analyzer view of all the radio conditions around you. I haven't done that to look at what his neighborhood, I meant his RF neighborhood looked like, and what the noise floor was at that point. 433 in the U.S. is not an ISM band. It's really only used for key fobs opening your door, and that's at a very low power. I was operating these actually below 100 milliwatts. I was okay, but I was operating these because I'm a licensed amateur radio operator, and this frequency falls within the ham band in the United States. But this is an ISM band for Europe. I got these for two reasons. First of all, I thought there'd be less chatter and traffic at 455, and the other thing was I was impatient, and Adafruit was out of the 800, 900 megahertz modules. I just said, well, I'm going to get the 433s. They might get better building transmission, penetration, and also there's liable to be less traffic in the U.S. on that. And so the only thing I've got kind of left to do, experiment with variations of the antenna other than just a quarter wave. Look at it through here, add that micro FCL adapter so I can use some external antennas to give me more gain and either omnidirectional, or if I'm going to try to point somewhere out, I'll build a little Yagi, try to point to it. Power manage the M0 cord, see if I can bring it down into microamps instead of milliamps. I haven't done a range versus throughput trade-off over distance analysis on them. And then I want to get what you've got, which are the up-band ones that are for GSM here, and see how that compares. I can also go ahead and get the official licensed version of the LoRa one that conforms to that. It's basically $15. Get a module that supports 6 low WPAN, which is IPv6 native, but it's not open source. It's proprietary also. And then figure out what the heck to do with these.
What about a ground plane?
Yeah, a ground plane would
Probably better than that.
yeah, if I had it. Anyway, so that's it. I don't want to take up any more time.
One more, I think.
It's probably running somewhere else, but
I think it was the next one on your own tab. I think it was the next one.
oh,
Yeah. Oh, never mind. Let's just wait a second.
But anyway, I won't take up any more time. Looking forward to playing with these and again finding out more of what their range and capability is going to be. But yeah, and like I said, what I didn't get to do was, instead of you having to look at the terminal and see that, I've got two of these actually, but I want to have it say my RSSI at the far end is, his RSSI at my end is, and they should be orthogonal, you would think. But that's it. Just a little guy here, and since he is running in the sort of Adafruit development environment where he can switch over power and everything, both of them are heart beating at the same time, so the one of my Jeep's doing the same thing. And maybe after the meeting, I'll drive or walk over the way and see how far I can get open air out here, but about a half mile I thought was pretty respectable with the quarter-way straight wire and ground plane, and like I said, the unit I was carrying it around like this. People thought I was playing Pokemon or something. The domain is a big place for Pokemon, but yeah, half mile each direction. I was impressed with them. Very limited antenna work.
Yeah, you have a hell of a Pokemon detector there.
Thank you, Grayson, it was really good. All right, so the last part of this meeting, we're going to probably go a little late. This presentation will probably take an hour, so I'll try to go fast. I wanted to give you an introduction to LPWAN and all the options that are out there, and a little bit more detail about LoRa. The guys who did presentations here will know more than I do. What I've done is collected information on the net and done a few experiments. I've gone to a LoRa boot camp where it was an intense day in San Francisco. They put so much information in your head that you just don't know. You don't know anything when you get down. You know less than you did when you went.
And were you surprised that nighttime in the middle of summer that it wasn't quite as warm as you thought it'd be?
It was nice. I really regret that I didn't get to ride a cable car. The day I allocated for it, the cable car broke.
Oh.
And I ended up doing other things, but I didn't get to go to Chinatown like I wanted. So as you see, there's a lot of different labels up here, and there are some that I didn't put up. I didn't find good graphics for LTM, and I'm not sure exactly what waitlist does. I think they're part of some of the other systems, but there's a lot of different devices up there. Just a intro slide. This is kind of a picture I pilfered just a while ago, and I found it when I was doing some quick research, and I thought it was a pretty good example of the different options that are out there and what they cover. So if you see LPWAN is distinctly down in the long range, low bandwidth category. And all the other stuff is Wi-Fi and Bluetooth and all the other things. So LPWAN uses ISM bands in general. We're talking about the free stuff. I should have clarified that a little better, but the general open standard stuff is using ISM bands, which is industrial science and medicine. These are bands that are allocated in the U.S. and in other countries, specifically for use in the domain of industrial science and medicine. And they're open and we can be used for just about any purpose you want, with limitations. But LoRa uses it, and so do several of these other systems. So open use with limits, 915 megahertz in the U.S., 868 in Europe. Hams can use pretty much anything they want. I said hams here, I actually meant, I changed this, it was 460 something before I made that comment. But anyway, everywhere 2.4 gigahertz. Wi-Fi is a universal ISM frequency. So that frequency works everywhere on Earth as an ISM open band. And that's an interesting thing to point out. Used by low range, use Sigfox and others. So you may have heard somebody mention Ingenu. I think somebody mentioned Sigfox at one point. And cellular industry uses their own frequencies. Okay? So LPWAN is for IoT, tiny data, low power. So sometimes they call them data dribblers. And the general thinking is around 2 megabytes a month maximum. Okay? They update slow. They rarely transmit. They use low output power to achieve long battery life, and they have very long range. That's the idea for LPWAN. The cost, these numbers are just, just to throw out there and see if they stick kind of thing. But what I'm seeing the industry pushing towards around a $10 module. That's a certified, ready to go module you can put in your hardware, with a connection cost of around $1.50 a month for that 2 megabytes. So that's what you should expect to be able to get as this progresses and moves forward. Some of these modules that we're talking about here in the $10 range can actually run your code. So you don't have to have the module and then your other processor to talk through the module. And the SymTech modules, generally speaking, they're self-contained modules. But some of the other modules allow you to actually write code, run your own application on the module. So then there's LoRa, which is low power. What I point here is that NB-IoT, which I'll talk about in a minute, and Sigfox actually are lower power specifications. So you can build devices that use lower power with NB-IoT or Sigfox.
Those don't seem to get as much coverage. I've never heard of them.
They're just now getting started.
Okay.
I'll talk about each one. Bandwidth for LoRa is good for IoT, i.e. small. The network is open. It's generally speaking an open standard. The radio chip is proprietary. It's made by a company called SymTech. So today, pretty much any module you get is going to have a chip on it made by a company called SymTech. Other companies are starting to do it. I think there's some arrangement with Microchip. And so Microchip will be competing with them soon. I think you can already buy Microchip parts. A friend of mine already has 2 notes from Microchip. But I think they're using the SymTech modules. I'm not sure. They are long range, limited by terrain, but think of a range in miles. Easy to use with or without a network. As you see, Grayson is using it, no network services. He's just talking directly between the units. And John is using it with his own protocol, so he's not using a quote network service either. LoRa is deployed like crazy outside of the U.S. There's lots of countries all over the world that have full coverage over their whole territory with LoRa right now. So it looks like it's going to win the game for what LoRa is good for. But the verdict's not out yet. There's a company called Cinet that is in the U.S. that's deploying a network here. And a good friend of mine runs their agricultural product development. So I know a little bit what's going on there, and the stuff I've been playing with is using Cinet. All they're really doing for me is they're acting as the gateway, not the gateway, the central server. So in a full network star topology system, LoRa really relies on having a server to orchestrate the connections between the devices. So it's a much more elaborate thing, as John was saying. It's a lot more effort involved in doing a full up LoRa than just using it as radio.
Are they fairly new?
Cinet is very new. So Cinet's an interesting story I'll go through real quick. Cinet started up as a company monitoring propane tanks. And they tried to use Wi-Fi and stuff and deploy a propane volume monitor in rural environments. And they had a great business model, but they couldn't make that system work very well. It was just too much trouble. And so they found out about LoRa and started using LoRa, and there was no solution for a simple server. So they built one, and they built a business around it, and that's what they are now. So here I'm showing them a lot of information on a single slide about LoRa, technical type stuff, but basically there's several different methods for transmitting over LoRa, and we talked about there are different bandwidths and different bit rates. But don't let the bit rates fool you. That's not how fast your data moves through LoRa. That's how fast the transmitter sends the bits, and it's got a very low duty cycle. So it comes on for a very brief interval, bursts out the data at a high rate, and then shuts up again. So that the average current is very low. So higher bandwidth gives you shorter range. So when you see on these things the higher bandwidth, that's definitely short range. Higher bit rates give shorter transmit on times, i.e. less power. You get less power usage at the higher data rates. Wider spreading gives redundancy. So the reason there's this spreading in here is the bits, your data bits are encoded into this spread spectrum modulation technique, and the more bits they have to spread it into, the more redundancy there is in the data, the more reliability you have in the transfer. But also the slower the data rate. So we say that the effective data rate is 0.25 kbps to about 11 kbps. So that's how fast it actually is. Adaptive data rate, ADR, that's a mode that you should be using when you have a LoRa network that allows the server to tell the remote how to transmit, what data rates to use, what power levels to use, so that it can optimize the communications path for power consumption. So there's something about the payload sizes. Typical payload sizes are 11 to 242 bytes, depending upon which configuration you're using in the spreading and whatnot. Range, 22 kilometers, 13.5 miles line of sight is like the spec. You can do a lot more than that depending upon your antenna configurations and things. And it says 1.2 miles through urban environments. So with buildings and typical structures and stuff, you should still be able to do over a mile.
That assumes optimum,
Yeah, it does.
perfect conditions.
This is radio company specs. So, so I don't know what their model for an obstruction is. It's a single sheet of plywood. So I don't know. But anyway, yeah. So security, and there's several layers of encryption built into the full-up LoRa. Each device has a unique network key, and that's like a developer key. You know, it's an API key. Then there's an application key, which is a key for your particular kind of application that you're doing. And then there's a device-specific key. The actual keys created in the devices for encryption are unique to each device. So even if somebody managed to steal one of the keys, they wouldn't be able to get any data from any of the other devices, because the device-specific key is part of that encryption.
So does all that security come standard with the LoRa Alliance?
Yeah, if you have a
code base?
full-up LoRa system and you like connect through SYNET or some other provider, yes.
That's all part of being certified, right?
It's all part of the certified LoRa standard for communications. So here we talk about what kind of device classes there are. There are 3 types of LoRa device classes. So they're pretty much all bidirectional. But when you talk about a low-high type, what that really means is that the device kind of fires and forgets at random. So it's a temperature sensor or moisture sensor or something like that. It comes up at some interval and transmits its data and then goes back to sleep. It does listen briefly after it transmits for an acknowledge from the server. That's why it's bidirectional. But the only time it listens is right after it transmitted. Okay, so it's not sitting there it's not even listening. It's just going to power up when it's got something to send it, and then see if the server responds, and then go back to sleep for a random interval to do it again later.
What about updating firmware? Would that work?
That's not something you would do with Class A, for sure. You might do that with a Class C type system, some other way.
So if you ever think that you need to update something, don't pick Class A.
Yeah, I haven't heard of anybody doing over-the-air updates with LoRa stuff at all. But I don't. I would
It's very
assume
low
it's
bandwidth, so your firmware needs to be very strong.
That's right.
In the event that when it does receive acknowledgments from the server, can you program it to do things based on that? Or,
Well,
okay.
the notion is that if it's got a measurement, it's going to try to transmit until that measurement's delivered. So if the measurement gets to, the server says we got that measurement, and it can shut up until the next interval
Okay.
for the measurement. So that saves a lot of power. It doesn't just keep transmitting. But let's say it makes a measurement once per hour, it might come on every 15 minutes and transmit the measurement until it gets an acknowledgement that that message was delivered.
Okay.
So Class B is scheduled receive slot. So the device effectively comes up on a scheduled time and receives a synchronization message from the server. The server says you're going to talk, the time now is X, and you're going to be able to talk. You're going to be able to communicate with me in these slots. And so the device comes on and transmits and receives messages from the server. When you're sending a message out to the device, it's going to queue up and wait for the slot when the server is expecting the remote to be listening.
It's basically traffic control. You can say you talk here, you talk here, you talk here. Nice.
The thing to note is that what they're doing is they're determining when the device is going to listen, which is kind of seems like the opposite. The reality, it's going to transmit when it's got something to transmit. And it's going to listen either when it's finished transmitting or on some scheduled intervals for commands to do things. And then Class C is basically it's on receiving all the time. So you can send commands to it at any time you want, and it can transmit when it needs to. But of course, the only time it can't receive is when it's self-transmitting. So that's Class A, B, and C. They're designed to support the notion of just sending the data when you need to and getting acknowledges and listening for commands from the server with narrow windows so that you save the time of leaving the radio on.
Are these separate physical devices, or can
No,
one device have?
most as far as I know, every LoRa device can support any one of those, but I don't know if that's a fact. I would assume that it's just software. None of these affect the radio.
Yeah, it's permanently battery life.
So this is just an example of a packet that I get. My device, I have a device that's sitting in my office, and it's talking through an MTech gateway, So I have an MTech conduit, as it's called, which is a gateway device that's a base unit that receives data that's connected to the Ethernet and sends the messages, the data that it receives to Semtech. And then I've configured Semtech with their gateway to send my data from my devices through my own MQTT broker. So all the packets that go from my devices to Semtech end up just bouncing right back to my own MQTT server. And this is an example of what came out.
So they're basically a middleman for you to make sure your stuff gets to your endpoint for you to do stuff.
Yep. So, and I don't need them. I could do this very thing without them. I wouldn't be necessarily using a LoRa protocol or provider. The reason you'd use somebody like Semtech is I could build a device and deploy it anywhere, in the United States that there's coverage, and I'd be receiving these messages. I don't have to put the bases out. And my base is part of their network. And they're very nice about that. They very much love it if people would buy these multi-connects, multi-tech conduits and install them and connect it to their network. Because the more bases units they have, the more channels they have for revenue from individuals. So I'm supporting their network. I do plan to put up a nice antenna. The building is in Round Rock, so the Round Rock area, when I get this done, in a few weeks, we'll have coverage for a LoRa base.
Fantastic.
On Cinet. But that would mean that you'd have to make a deal with Cinet to use it. I don't know if you care. I don't know how I give it to you, but when I get it configured, ultimately I don't care about the data. It's irrelevant. If you absolutely filled the packet, we wouldn't even notice it.
Will they have a subscription service?
Cinet does, yes.
Okay.
There'll be like $1.50 a month kind of fund. So I mentioned LoRa is a star network topology. That means is there's a central point that all the units transmit to. That's if you're using LoRa, but you don't have to do that. Grayson is doing point to point. There's nodes. These are modules that have those Semtech chips. There are gateways. Cinet and other people provide those gateways, but it's a physical device like John's module or the multi-unit connect that I have, multi-tech conduit that I have.
Which is that?
How much is the conduit? I don't know. They gave it to me at that boot camp. It costs $1,000 to go to the boot camp. You can,
$700.
Yeah.
huh?
$700 retail, I think.
So I'm sure I got quite a bit. I'll show some of the parts that I got. So you can build your own, like he did with the Raspberry Pi. The directions are out there. So if you want to build your own base, the base device that does more than just receive the messages. It actually orchestrates the network. Does things like if you have multiple base unit receivers, it can pick which one is the right one to communicate with the remote. So the one that talks, and it can send messages to the remote and the synchronization data and adaptive data rate management. So it does a lot of stuff that provides this functionality in the network. So it's not just an in-port radio. That you could do just by hooking up another radio. Sigfox is another one out there. Sigfox is LoRa is a French system too, but Sigfox is French and it's deployed in Europe and in a lot of places. It has a lot of coverage over there, no coverage over here. They plan to deploy here, but they're meant to be super low power, super low data rate. It's an open protocol with lots of radio suppliers. So the radios themselves are very easy to implement in open standards, supposedly. But of course the network itself is closed. It's Sigfox. You'll be making a deal with Sigfox. You'll be able to buy chips from lots of places. Okay? NB-IoT. This one here is the sleeping giant. NB-IoT may obfuscate the need for any other system. It's the cellular industry. So it's coming soon. It's extreme low power. It's got more bandwidth than Sigfox. It is an open standard, and it's also in development. And there'll be a lot of suppliers for it.
Are they planning to deploy this like on their cell towers? Or
Yes.
Okay.
So wide deployment is less than 2 years away if you believe the industry got people. So there's different parts of the industry from my perspective. Some of the guys that are inside the industry said there's no way they'll ever be able to do it. The guys that are, the talking head part of the industry, they say, we're going to do it, starting this year. And the people who make the chips say we're already ready. There's some deployments, small deployments, but they expect wide deployment in 2 years.
But it
That's a
looks like it's-
cellular company doing it, so they'll have wide coverage. And the question really boils down, can they handle the pricing model? For this to be effective, you know, the expectation is $150 a month.
But it's in the, I noticed it's in the cellular frequencies, it's not in the ISM band.
Right, it's a different frequency, it's gonna use a chunk of the band that's being freed up now, when they get ready to, rearranging the frequencies to get the
Okay.
new 5G stuff. Whatever that, I don't know what the deal is. There's another one called LTEM, and it's like a little brother of LTE, it's intended for, you know, bandwidth type usage in the smaller domain. It's still small, but it's able, you're gonna send megabytes of data with this, you know, per second.
I think I saw a commercial for that for Verizon over the weekend.
Yeah, maybe. So that's coming, but the one that'll probably, if they can actually do it, if they can actually wrap their mind around selling a service that costs about $50 a month to customers that are used to selling stuff that costs you $60 a month to. AT&T has a marketing paper, they say they have 2 million customers now on cellular data. And I'm not talking about cell phones, I'm talking about devices monitoring streams and water levels. And those guys are paying a lot of money. And Verizon, or the cell phone industry, has to go out and say, we're gonna destroy all those customers, drop all those accounts, and move them to NB-IoT for a couple of dollars a month. You know, it's hard to believe that they can do it fast.
Yeah, my system, we're targeting $5 a month,
Yeah.
and we'll be up in less than 2 years.
So playing with LoRa, so ideal for getting started. It's very easy to do stuff with LoRa. You just literally go to Adafruit and buy a couple of radio modules, these modules will have Simtech chips on them, and the Adafruit has a nice M0 feather with LoRa. That's what this guy is, and this is what Grayson was using. The reason I went and bought him is Grayson showed me his, and I was like, oh, all right. Adafruit has them. So I ran up and bought them, and as he told you, this little thing here is the LoRa module, and there's a processor. It's got a lithium battery charger on it. So it's very easy to make an application with one of these guys. I have not gone to the point of getting that guy to connect to my Simtech network stuff. I don't know how hard it's going to be. I suspect I'm going to lose more hair. So I mentioned Ingenu. This is the Ingenu development kit.
It says on-ramp.
Yeah, OnRamp is a company that owns Ingenu. So this is the Ingenu development environment. So Ingenu has a 2.5 gigahertz based LPWAN technology. As somebody else mentioned, that's going to be probably a problem for them. But the good news is it works worldwide. That's one. Two, that each tower, because of that frequency range, you can easily sectorize. So the reason cellular and other systems are up at those high frequencies, they can build antennas that see in specific directions. So theoretically, these guys can handle 2 billion connections per second. So they won't be swamped by IoT. When LoRa, if you really look at the numbers, it's like, if we're going to have 2 billion connected devices, how are they going to do that with LoRa? I don't know. So there are some questions there.
And everybody's waiting, nobody wants to bet on technology and have to replace it.
That's right. Eventually,
Yeah.
somebody's going to have to bite the bullet and make the choice. Let's see what we got here.
But it seems like LoRa is getting a lot of deployments today. I mean, this other stuff. seems
Yeah,
to be
LoRa
going
is
on.
going in a lot of places. Even South Korea is covered with LoRa. Europe has lots of full coverage LoRa. Orange, the network Orange, you probably heard of, they're putting LoRa in all over the place. In fact, the boot camp I went to was put on by Orange.
Oh.
So I just mentioned the boot camp. We went to, Orange put it on, and we were using Cinet as a central server, and data was piped to MQTT for our workshops.
So you're like the single node, Senate node here in the area, or?
Yeah, as far as I know. I mean, that's one thing I dislike at this point with the tools. I can't scan. It's very difficult for me to tell if my base is actually working. So sometimes if I get questions, I have another device. I have multiple devices. And I'll turn on one that I'm not going to touch him. His only purpose in life is so that I can get an update through the Cinet system and see that my base is working. So the debugging tools are weak. So range question. We talked about range. Is this the go station? So that's pretty much the end of my presentation. So is there questions?
Have you ever looked into development in the UHF dam?
No.
I know that Rice University in Houston is doing some work there. You get, a couple mile range in UHF, a lot higher frequencies.
Talking about the TV white spaces, the frequency got freed up by the
Yeah.
digital TV, yeah.
Right.
It's still kind of new, I haven't seen a lot of stuff out there.
They're a little
Hard to get.
it would definitely get you a lot higher data rates and possible for.
Yeah, Microsoft did a big push and with them, and then it all just kind of disappeared. I haven't heard anything for over a year.
I was curious.
One
Seems to
thing,
have died out.
one way, I got some show and tell stuff here if you want to see it. This is the MTech. This is the module from MTech that's cooperative with them and Syntec. It's also a Cortex processor, but it has a embed. So you write your software and you just drag it over almost like a thumb drive.
Is that one of your gifts?
Yeah. And so this is what I'm doing my development on right now, and I had a lot of trouble getting it connected. In fact, I've just got it connected today.
And that's a LoRa?
It's a full up LoRa, goes through the Cinet, and it has this little board has an Arduino adapter thing on it, so this is a sensor module and lots of different sensors. So it's working just fine now, and the bad news is I don't know exactly why it wasn't working yesterday. So there's a lot more work for me to do there.
It's a software issue.
Definitely short between the headsets, or an ID10T error, I'm sure. So, but this guy I haven't fired up yet, but this is the Ingenu one. That's about all I got for show and tell. This is so that's it. Any other questions?
I have a question. So, with this LoRa, since you have to get certified and all these things, what's the impact on end product cost when you've got a simple sensor that's sensing light or temperature or whatever, right?
Well, the radio module's certified, you don't need to.
Yeah.
Well, yeah, but if you're going to sell a product, an IoT product that connects to this LoRa, right, network, that has to be certified also.
Yeah, but
right? So the question is,
I think I can answer your questions. For initial development and for quantities, less than, a few thousands, in the 20,000s range, you would buy a module from one of these Syntec or Microchip, and you put it in your product. It'll be FCC certified and LoRa certified.
but it's still going to be like a $19 module.
$10.
Right? Okay, so what was the $19 price that?
That was for the Feather. It was an uprider on the Feather to get the full LoRa certified radio.
Well, that's what I mean, right? So
Yeah, that's Adafruit. That's buying it from Adafruit.
And that's a whole dev environment, right?
That's the whole dev environment. It's another 19, but.
Oh, okay. So that it didn't sound like that's what he was saying.
Yeah,
He was
and
saying
these
the
numbers I'm
modules.
talking about when we have deployed. So over time, the numbers are going to vary, but the target is to be around $10 for a module for a low volume customer.
Yeah, because this board right here was $30, and that's GPS, LoRa, antenna, everything, And that's for the Pi. Adafruit's got other.
So I get a sense, so I have a LoRa sensor, I wanna hook up to this SENet,
Cinet.
and I wanna provision my device onto their network and pay my $1.50 a month. How do I do that? Do I go to their website?
Yeah, you go to their website, you get set up with a dev portal, and then from there you'll register your device and your gateway if you have to put your own gateway up. So it's pretty darn easy. I don't know, I might even go to show you. Computer internet. One second.
Big shot.
I guess we'll try.
It's better than
So this is my cord. So you see the top thing there is my multi-tech conduit. That's my base unit. And then down here below are the two nodes that I've got registered with them. The top one is the one I mentioned that I just keep to prove that the thing's working. And you can go look at the data from it. This guy's got some, it sends a protocol that's Synet's protocol for measurement stuff. And eventually you'll get a graph here that shows, various data parameters coming from that device.
And
So
is that
so all
actually-
the, oh, sorry. I was gonna say, so all the data you have to get through this Synet
Well,
website.
technically, yeah, you would either use a REST API to get to your data, or you would just have it forward your data. It'll also do webhooks, so you can have it hook the data to your.
Mind if I do a diagram on a whiteboard? That might help.
Sure, go ahead. So you can get it any way you want to get your messages. This little chunk right here, this PDU chunk, that's the actual packet. It's a hexadecimal version of a binary chunk that was delivered by my device. It's unique to my device, with my data. The rest of this is a protocol from the Synet server. So technically, my device is sending that piece, and all the
What
rest
was
of
the
this
name of
is
the conduit? Semtech?
Synet.
multi-tech. So you can see there that the signals, and I've told it to use MQTT. I didn't be able to see that.
And if I heard you, so if I get a device, so I can search for gateways in my area, or that's what's hard?
Though I don't know how to do that.
Okay.
Yeah, check out the Things Network for that.
What?
The Things Network or Things Network. They've got a couple nodes in Austin. It's very spotty coverage, but they have some.
But that's different from Synet, right?
Yes.
So if I get onto the Things Network, but there's a Synet node somewhere, I mean those two are just totally
Basically,
different.
you've got four pieces. You've got your device in the field, let's say your
Sure.
sensor, like you said. You've got some sort of gateway, which can be anything from, this right here to, do you have the gateway here with you?
No, I didn't make it.
Okay, to these other providers. And of course, you've got your tower here, right? And then you have some sort of service provider, whether that's Things Network, Synet, whatever. And all they do you have your Synet portal? Can you show like your endpoint or something?
Picture what it looks like. What are you asking for?
Basically, like where you configure your MQTT endpoint or whatever, wherever Synet sends the data to. So you still have to maintain your own infrastructure somewhere back here with your own logic.
Right.
So there's really four pieces to it. And the gateway could be several vendors, and the router, for lack of a better word, could also be several vendors. He's just showing one full stack.
Right.
But unfortunately there's 5 or 6 or 10 different options.
Got it.
Hope that clears things up.
Yep, no, I get it.
So I just connected to my MQTT broker. I have some other IoT devices that are puking out data continuously. But here in a few minutes, we're like, we'll see a big block in there. That would be one of the.
So Synet's talking to this?
Yeah, I may not have it actually running. In fact, I don't. I'd have to power this up to get any data. So no, I don't. I'm not going to be able to show any data.
So do you need to have an MQTT broker and have an account with Synet to do all of this?
It depends on what you mean by all this.
Well, so you had one of the last sessions you did, you showed MQTT over Wi-Fi, right? And so you just needed your Wi-Fi connection, and you talked through a broker, right? But you didn't have like another account that you had to get into before you did that, right?
What I could have done to make it clear, I think, is I could have taken one of these radios, right, and rigged it up to send MQTT messages.
Okay.
So this radio is going to talk through directly to my remotes. So I could make this a base, use my own protocol, which is what John did with his systems, and also what Grayson's doing. So I could use LoRa and take one of these $30 things and put a good antenna on it, stick it in the box, call it my base, and however it gets connected to the internet, ESP8266 or something, it'll shoot the data through my broker. So all that Cinet is doing for me is they're being the endpoint for the base units that's receiving my device. And the reason I want to use them is because when I move my device to Sioux Falls, South Dakota, and stick it in a field and to measure soil moisture or something, there's a LoRa base unit that's owned by Cinet.
They're the cell phone provider for a lot.
They're the cell provider. They're the
Backhaul.
Oh, so you just take your box, put it wherever you want, and they can find it and get
It'll
it.
automatically connect to your thing.
Yeah, that's why I wrote the little tower thing there.
Have you seen any of the Wi-Fi roaming groups, Fanatos and this kind of thing, where you can use other people's Wi-Fi? Same sort of idea, just online.
Yeah, it's just like a cellular thing. If you fly an airplane someplace and get out of the plane, your phone's gonna work. So the same thing with LoRa, if you're using a big provider like Cinet, once they have coverage, they don't have a lot of places covered yet, but when they have large coverage, that'll be true. And then one of these other systems, like if NB-IoT takes over, that'll be just like with your cell phone, it'll take them. The bad news is, with the cellular companies, you're gonna have the same problem you have now. You have to pick Verizon or AT&T or somebody, and that's gonna change depending on where you're at. Different places, different prices for data, different coverage, different radio frequencies. You'll have to have the right modem. So today, if you're gonna build a box that worked anywhere, you'd have to use 4 modems.
Wow.
The other problem with the cellular is they are always upgrading. And so if you wanted something to last 5-6 years, SOL.
Yeah, it could be. So that's one of the differences. You're not gonna get away from the pain with NB-IoT of having to have the right equipment.
It's crippled very quickly.
And even under best case scenario, they won't have perfect coverage everywhere for, a decade. And they probably won't even have it then, despite their marketing.
And that's really where we come in is the flyover country, is rural areas. That's really what we're targeting, covering the entire Commonwealth. Very low bandwidth, a few megabits, which is a lot higher than LoRa, but not, this is not for,
Just do LoRa.
Huh?
Just do LoRa from the.
Well, yeah, exactly. So I mean, having that. Well, we'll have at least one LoRa radio on every orbiter and every tower. So
If we could get it to work all the way to the soil moisture sensors with a 5-year lifetime, that would be.
as I said, we have about 12 initial customers all running large or want to run large IoT field deployments. Yeah, it's very cheap. It's another $10 on. This orbiter is over $1,000 all in. So another $10 for another radio, no one cares, and it's very low power. So.
Any other questions?
So that gateway said it's about $700. Have you seen anybody with a plan to?
Yes, there's an open source group that's planning to make a gateway for $200. So the gateway itself it's not really hard to produce. You just a Raspberry Pi with a hat on the right side.
But is it a certified gateway? Because that means multiple channels.
That's a function of the radio that you put on it.
Right.
So yes, it would be certified.
Get the presentation.
Second?
Have access to.
Oh yeah, I'll give it to David. I'll put it in the doobly doo.
Awesome. Thank you, David.